In this video, we are going to talk about how the addition or deletion of one base pair can produce a shortened mutant protein. In this example, we have been given the amino acid sequence for a normal strand and a mutant strand. To identify where the mutation took place, we must use the codon dictionary to list out the possible codons that code for each amino acid in our sequence. It is important to point out that although it is not explicitly written, the mutant strand has an implied stop codon at the end because this is the last amino acid coded for. So now we see that both strands start with the amino acid methionine, abbreviated MET. So looking at our codon dictionary, we see that only the codon AUG codes for MET, so we can list this under each strand. Now that we have listed out all the possible codons for each amino acid, we need to compare each strand to see what changed to make the mutant protein. So starting with the first amino acid, we have MET here and MET here. And the codon is the same, AUG, so these line up without a problem. The same is for the second amino acid, TERT, because UGG and UGG line up. However, we have a problem when we get to the third amino acid, because we have IL here and Phi here, and as you can see, different nucleotides code for each amino acid. So as you can see, the first nucleotide in this codon is A, and the first nucleotide in this codon is U. So therefore, U and A will not line up. Now, however, if we move one to the right in this codon, the middle nucleotide is U for each one. Therefore, these U's could line up with those U's. And if that is the case, then our mutation is an insertion of the base pair A. So, what we need to do now is we need to move to the right of the mutation, which is the insertion of A, to try to get these nucleotides to line up with these nucleotides in the normal strand. So what I'm going to do is I'm going to put a dot under each one that we know lines up with each other. So starting here, we have U and U, so we need the U. And here we have U, U, and U, which is good because these two U's will line up. Now here we have U and U again, so we're going to need to use the U. And here we have U, C, or A, but we want the U, so these two U's can line up. Moving one over, we have a U and a C here, but we only have C's here. Therefore, we need the C here to line up with the C here. Now would be a good time to pause the video and to try the rest of this on your own. Now we can write out the mRNA coding sequence of the mutant strand. So we're going to start with the 5' end, and then we have AUG, UGG, and then AUU, CAC, and UAA, and then our 3' end.